Introduction to matter. Everything around us is made up of matter. A matter is made up of small particles known as molecules. A number of molecules are arranged together in a definite structure to form matter. In simple words, we can say that matter is something that has mass and occupies space. Arrangement of molecules in matter decides its form and properties. These molecules are made up of atoms. Thus, we can say that atoms are the smallest unit of matter. Brick, wood, oil, water, air are different forms of matter existing around us. States of matter. Everywhere you can feel the presence of air. Flowing water, frozen ice are some other examples which we experience in our daily life. All of these are examples of matter, but they belong to different states. Frozen ice is solid, while flowing water is liquid. Air is a mixture of various gases. On the basis of our daily experience, we can say that matter exists in three states, which are solid, liquid, and gas. Properties of all the three states of matter differ from each other in every aspect. This happens due to difference in their molecular arrangement. Let's have a look over the behavior of matter in all the three states. No more. Plasma is the fourth fundamental state of matter. First described by Irving Langmuir in 1920s, plasma is an ionized gaseous state which does not exist freely on the Earth's surface under normal conditions. Solids. Substances having fixed shape and volume are known as solids. Solids occupy definite space and are incompressible in nature. Molecules of solids are held together by strong intermolecular force, and there exists negligible spacing between them. That is why solids are incompressible in nature and we cannot change their shape. Table, chair, glass, iron nails, pencils, etc. are some examples of solids. Some solids of lower strength or soft solids deviate from their original shape and get deteriorated on application of force. Some solids like sponge can be squeezed. This happens due to air voids present in sponge. While squeezing sponge, we actually squeeze out air from it. Example: table, chair, book, pen, pencil, etc. Liquids. Substances with fixed volume but indefinite shape are known as liquids. Liquids occupy definite space and are slightly compressible at high pressure. Molecules of liquids are held together by comparatively weaker intermolecular forces, and there exists more intermolecular spacing than solids. The intermolecular spacing adds flexibility to liquid molecules and enables them to flow. That is why liquids have no definite shape. Due to their ability to flow, they take the shape of the container in which they are placed. No more. Due to their ability to flow, liquids fall under the category of fluids. The term fluid specifies those substances which can flow. Example: water, milk, juice, oil, etc. Gases. Substances with neither fixed shape nor fixed volume are known as gases. Gases occupy the entire available space and are highly compressible in nature. Molecules of gases are held together by very weak intermolecular forces, weakest among all states of matter, and there exists large intermolecular spacing between gaseous molecules. This large intermolecular spacing causes poor intermolecular force between molecules of gases and makes them highly compressible in nature. Due to weak intermolecular force, molecules of gases move freely in the entire available space and thus fill the entire volume. No more. Gases are also capable of flowing in nature, which makes them a part of fluid category along with liquids. Example: oxygen, helium, nitrogen, carbon dioxide, etc. Interconversion of states of matter. All the three states of matter can easily be found in nature. They are interconvertible in nature, which means they can be converted from one form into another. This whole process is known as interconversion of states of matter. This interconversion may take place in various manners. Some of them are explained here. Amazing fact: water is the only matter present on the earth which naturally exists as solid, liquid, and gas. Melting. When heat energy is supplied to a solid substance, energy of its molecules increases. Due to this increase in energy, expansion takes place in solids. This increases space between molecules and leads to conversion of solid into liquid form. This process of conversion of solid into liquid is known as melting. Example: melting of ice. Vaporization. When heat energy is supplied to a liquid substance, energy of its molecules increases. Due to this increase in energy, liquid molecules get separated from each other. This lowers the intermolecular force and leads to conversion of liquid into gaseous form. This process of conversion of liquid into gas is known as vaporization. Example: formation of steam from water. Vaporization takes place in two manners, which are known as boiling and evaporation. Vaporization below boiling temperature is called evaporation, while that on boiling temperature is called boiling. Freezing. When heat energy is extracted from a liquid substance, energy of its molecules decreases. Due to this decrease in energy, movement of liquid molecules gets restricted. This gives them stable and fixed shape and leads their conversion into solids. This process of conversion of liquid into solid is known as freezing. Example: freezing of water. Condensation. When heat energy is extracted from a gaseous substance, energy of its molecules decreases. This causes decrease in intermolecular spacing, which leads to conversion of gases into liquid form. This process of conversion of gas into liquid is known as condensation. Example: formation of water from steam, dew, fog, clouds. No more. Substances those exist naturally in gaseous form are called gases. Gaseous form of water and other naturally found liquids are called vapors. Activity. Aim: to understand the process of condensation. Need: Bunsen burner, test tube, stand, water, cork. Method. Take a test tube and fill it up to half with water. Fit it to the stand and place Bunsen burner below it. Burn the burner and wait until water starts boiling. Now cover the test tube using the cork. Remove the cork after some time. Observation: water droplets get collected on the bottom of the cork. Conclusion: after stage of boiling, water gets converted to steam. This steam gets collected at the bottom of the cork and due to lower atmospheric temperature converts back to the liquid state. Solute, solvent and solution. Two or more substances mix together in any proportion to form a solution. A solution is formed by mixing solute and solvent together. The substance having dissolving nature is known as the solute. The substance in which solute dissolves is known as solvent. Thus, we can say that solute plus solvent is equal to solution. Example, sweet milk is sugar plus milk. Salty water is salt plus water. Liquid glucose is water plus glucose powder. Solubility of a solution is the capacity of solvent to dissolve solute in it. In other words, that maximum extent up to which a solute can be dissolved in a solvent to form a solution is called its solubility. Stirring is used to increase the rate of solubility. Heating increases the rate of solubility as well as extent of solubility. No more. Solutions are homogeneous type of mixtures and are uniform in nature. Applications of interconversion of states of matter. Interconversion of states of matter provides us an effective and useful way to meet our needs. It is widely applicable from our daily needs to new inventions. Some of major fields of its applications are as shown here: metallurgy, medicine, plastic industry, space science, construction, etc.